This lesson covers Section 2.1 Properties of Matter and Section 2.2 Mixtures from our Pearson book. Our learning goals are to understand that all samples of a substance have the same intensive properties, know the two classifications of mixtures, and know some methods to separate mixtures into their component substances. Let's take some notes on that first learning goal. By the end of the lesson, a goal is to understand what intensive properties are. So let's discuss some vocabulary word. First, what's an extensive property? An extensive property is a characteristic of a substance that depends on the amount of the substance. The two extensive properties that we'll use most often are mass and volume. Does it make sense that if you change the amount of a substance, that would change the mass or the volume of that substance? Next, intensive property. An intensive property is a characteristic of a substance that depends on the chemical composition of the substance. Unlike with extensive properties, it will not matter how much of the substance you have. All samples of the substance will have the same intensive properties. For example, it's an intensive property of the substance water that it's a liquid at room temperature. The distinctive gold color of the substance gold is an intensive property of gold. It's an intensive property of copper that electricity can pass through a wire that's made out of copper. Another vocabulary word is physical property. This is any extensive or intensive property that can be observed without changing the chemical composition of the substance. For example, it's a physical property of the substance water that it freezes at 32 degrees Fahrenheit. It's a physical property of the substance air that it's a transparent gas at room temperature. It's a physical property of the substance that makes up our tabletops that it's black colored and hard. We can observe these different properties without changing the chemical composition of the different substances. You can contrast that with a chemical property. This is any intensive property that can only be observed when a substance undergoes a chemical reaction to create one or more new substances. It's a chemical property of the substance wood that it can be burned to create charcoal. That's not a physical property because you cannot observe that property without burning the wood. It's a chemical property of the substance hydrochloric acid that it will burn your skin if you spill some on your hand. It's a chemical property because you don't observe it unless you actually react the acid with the skin of your hand. In all of these different definitions, I've referred to the word substance. A substance is matter that has a uniform and definite composition. The word uniform means that the composition is consistent throughout the entire sample of that substance. The word definite means that the substance will always have the same composition. Whatever the components are that make up the substance, they will always be in the same proportion in all samples of that substance. Next, let's do some check for understanding questions. In a graduated cylinder is 10.0 milliliters of water. It has a mass of 10.0 grams. Identify two extensive properties of this sample of water. I'll pause the video for you to answer that question, and then we'll discuss. Next, let's consider examples of intensive properties. Identify two intensive properties for each substance. I'll pause the video, and for each of these items, list down two properties that depend upon the composition of the substance, not upon the amount that you have. The next learning goal for the lesson is to know the two classifications of mixtures. First, a mixture is a physical blend of two or more substances. Mixtures can be classified into two different types, heterogeneous and homogeneous. A heterogeneous mixture is a mixture in which the composition is not uniform throughout all samples of the mixture. As an example, think of chicken noodle soup. If you scoop some soup from the top of the container, you'll get some broth, maybe some noodles, maybe some chunks of chicken, maybe some vegetables. if you scoop from the bottom of the container, you could get a different proportion of broth, noodles, chicken, and so on. The composition of the soup is not uniform throughout the entire sample of the soup. A homogeneous mixture is a mixture in which the composition is uniform throughout all samples of the mixture. As an example, think about dissolving salt in water, stirring it up really good so the salt is really mixed in there well. This is a homogeneous mixture because throughout the entire container of salt water, there's going to be the same proportion of salt to water. Next, I'm going to pause the video for a few minutes for you to answer these check for understanding questions, and then we'll discuss them before we get back to the video lesson. The final learning goal for the lesson is to know some methods to separate mixtures into their component substances. A key idea is that mixtures of substances can be separated if the components have different physical properties. Now, there are many ways to separate substances based on differences in physical properties. We're going to focus on two of them. First is a process called filtration. This is the process of separating a mixture into components based on the difference in particle size between the components. When you were a little kid, maybe you went to the beach and you had what was called a sieve, which was a little plastic pail with holes in it. Water and really small sand particles would go through the holes, but larger sized chunks would get trapped on top of that sieve. Those of you with an interest in cooking know that there's something called cheesecloth, which is just normal cloth that lets water and very small particles pass through the fibers of the cloth. Larger particles cannot pass through the cloth. The projector that's in the ceiling of the room, or a vacuum cleaner, or an automobile engine all have air filters that allow the extremely small particles of air to pass through but trap larger dirt particles. Another process that can be used to separate mixtures is called distillation. This is the process of separating a mixture into its components based on the difference in boiling point between the components. As an example, think of salt water. When you boil salt water, the water, which has a much lower boiling point than salt, will vaporize first. The water will turn into a gas and float away into the air, leaving solid salt crystals in the container. In our science labs this year, we'll use distilled water. Water that comes straight out of the tap contains a lot of impurities. But when that water is boiled, the water will vaporize, but can be collected and condensed back into a purer form of water. All of the impurities will remain in the original container. This concludes the lesson about properties of matter and mixtures. There are a few more check for understanding questions in this note packet for you to answer, and then we'll discuss them.